Record. Hello friends, this is lecture number 5 of deep learning and the topic of today's video is sigmoid activation function. So in this video we will go through what is sigmoid activation function, what is sigmoid derivation and its numerical. So what is sigmoid activation function? Sigmoid activation function is a logistic function, is a non-linear function used in neural network and it transforms the input of the neuron between 0 to 1 means output of the neuron is between 0 to 1. So here in this example, here in the diagram you can see there is input, there is weight, and this weight and input are combined. Then bias is also added, and then it is passed to sigmoid activation function. So once the this sum is passed to sigmoid activation function, it will give you output between 0 to 1. So what is the formula? The formula of sigmoid activation function is del of z is equal to 1 plus 1 upon 1 plus e raised to minus z. So what is z? Z is a weighted sum of input that we have calculated here. So here in the graph you can see the output ranges from 0 to 1. So it is used in probability interpretation and binary classification problem. So what is the formula for sigmoid activation function? The mathematical formula of sigmoid activation function is this one, del of x is equal to is equal to 1 upon 1 plus e raised to minus x. So del of x is sigmoid output, x is the input to activation function, and e is the Ural number. The approximate value of this Ural number is 2.718. So del represent the sigmoid function here. So why do we do need the sigmoid function? Why it is required? What is the need? So it introduces the non-linearity. Okay, means uh, in traditional function the output is either 0 or 1. If you take the example of step activation function, output is either 0 or 1. But you see, the output of sigmoid activation function is between 0 to 1. So again, it convert the any real value input between 0 to 1. It is used in probability and it enables binary decision. So if you want to check whether the email is spam or not, so here you will require binary decision spam or not spam. So that's why the sigmoid activation is function is required. Again, the formula remains the same. So input and weight are combined, and then bias is added, and then it is passed to sigmoid activation function. So sigmoid activation function is applied on the neuron. So what is the shape? So you can see in the figure, the shape of sigmoid activation function is S shape. Okay, and output ranges from 0 to 1. So key characteristics, this curve is S shape. The curve is also smooth. There are no breaks or gaps in the curve. Has well-defined derivative at every point and suitable. It is suitable for gradient-based learning. So what is the advantage of sigmoid activation function? So first advantage of sigmoid activation function is output between 0 to 1. It is smooth function. You can say S type of curve. There is no gap in between the curve. The derivative is also simple. And it is used mainly, it is used for binary classification. So these are the advantages of sigmoid activation function. Now, what are the applications of sigmoid activation function? So sigmoid activation function is used in binary classification, probability estimation, binary output neuron. If you want the output between 0 to 1, then again sigmoid activation function is used and it is used in logistic regression. And so these are the applications of sigmoid activation function. Now, next is the numerical. Let us take one numerical how to use the sigmoid activation function. So here is the example file sigmoid output for x is equal to 3. So value of x is here is 3. So this is the formula del of x is equal to 1 upon 1 plus e raised to minus x. So we have to substitute x is equal to 3 in the formula. Then here e raised to minus 3 is 0.0498. So we have to calculate del of 3. So del of 3 is here you can see del of 3 is 0.9526. So this is how the sigmoid output for x is equal to 3 is calculated. Then find out the next numerical is find out the sigmoid output for x is equal to minus 3. So here x is minus 3. So again here value of x is equal to minus 3. Put it in the formula. The formula is del of x is equal to 1 plus 1 upon e raised to x. It will become e raised to x here because the value of x is minus 3. So del of minus 3 e raised to 3 is 20.8051 plus here 20.0855. So del of minus 3 is 0.0474. So this is how the values are calculated for sigmoid output x is equal to 3. Now next is what sigmoid derivative. So formula for sigmoid derivative is del dash of x is equal to del of x plus 1 minus del of x. So first of all we have to calculate del of x using that formula 1 upon 1 plus e raised to minus x. So here is the example. Suppose del of x is equal to 0.8. So we have to calculate the value del dash of x, that is sigmoid derivative. So it is 0.8 into 0.2, that is 0.6. So this is how the sigmoid derivative is also calculated. Now next is find out the sigmoid derivative for x is equal to 2. So this is the example. So del of, first of all calculated del of 2. So del of 2 is 0.8808. It is calculated using this formula del of x is equal to 1 upon 1 plus e raised to minus x. And then derivative is calculated del dash of 2 is equal to del of 2 into 1 minus del of 2. That is nothing but if you substitute the value, you will get del dash of 2 is equal to 0.1050. So this is how the sigmoid derivative for x is equal to 2 is calculated. Now next is numerical based neuron. Now let us see here in this example the input are given x1 is equal to 2, x2 is equal to 1. Weight is also given 0.5, W2 is equal to 0.4, bias is also given minus 0.2. So first of all calculate the value of the z. Z is W1 x1 plus W2 x2 plus B. So if you do if you combine it, then you will get the value 1.2. Now next is you have to calculate the value of y. So formula is 1 upon 1 plus e raised to minus z here. So here, if you calculate e raised to minus 1.2, it is 0.3010. So if you combine it, you have to combine it with 1. So y is equal to 1 plus 1 upon 3010. So value of y is 0.7685. So this is how the numerical based neuron is solved. Now next is how sigmoid function can be used for binary classification. The question here is we have to identify whether the given email is spam or not. So here x1 is given, x2 is given, or w1 is given, w2 is given, bias is also given. So using that formula we have calculated using sigmoid function the value is 0.924. So here we have applied threshold that if output is greater than equal to 0.5, class is 1. That is uh, email is spam. If output is less than 0.5, class 0 means email is not spam. Here the value is 0.924. So it is greater than 0.5. So that's why the conclusion is the email is spam. So this is how the it is used for probabilistic output, and it is used for a binary classification. So I do hope you understand sigmoid activation function. If you like the video, then please subscribe, like, and share. Thank you.